All right, I sent all of you an email last week. Unknown to me, it's a little bit repetitive because these aren't that good of articles, but I put them in there twice. And it's called Some Useful Chrome Developer Tools URLs for Class Monday, 11/6/2017, which is today. And just to very, very quickly just run by these for you. This is the DevTools overview page. DevTools is a debugging tool from Chrome. All right, it's designed to be used with Chrome. All right, and as it says, it goes through the different windows and the stuff that's in there. All right, so if you're interested, then there's a section that's just specific in there to JavaScript. So if you want to find out how to do some stuff with JavaScript, you can look through that URL. We're going to go through some of this stuff in class today. There's a couple pretty good articles from a thing that's called Toots Plus, Toots for Tutorials. And it's the Modern Debugging Experience Part 1, which is all on Chrome Developer Tools, and Part 2, which is specific to JavaScript with there. Again, very well written articles. Then there's an Introduction to Chrome Developer Tools Part 1, which is interesting because I never found a Part 2, but that's fine. There is a thing on, this is a PowerPoint basically presentation in PDF format on mastering Chrome Developer Tools. This, if you want to do nothing else, kind of nice. It's a thing from Code School. It's sort of one of those games that you play, but it teaches you about it. That's not bad. And then finally, this is a free course that's out there from udemy.com. All right, I haven't started it, as you can see, but I found it out there. So again, these are things that are available to you. All right, get rid of that. Okay, so that said, let's jump into Chapter 4 of the book. I will tell you too, I get these nasty grams when I don't turn in attendance, but I think there's a bug in their program, because if you come in late and I have to go and readjust it, for some reason when I save it, it's not saving. So I keep getting these nasty letters, nasty emails from one of the vice presidents telling me, why aren't you doing well? So from now on, at 8:10 every morning, I'm turning in attendance. So if you're not there, you're not here. You know, and I don't mean to sound like a hard ass, but I don't care anymore. You know, and you know you're supposed to be here. You know you're supposed to be here on time. Stuff happens. I get it. All right. Now, there are exceptions. Jesse came in the other day and showed me a ticket, you know, and mentioned that he got to have a nice talk with the officer who gave him the ticket. So sometimes things can't be helped. But you know what? It isn't my problem that you overslept. It really isn't. And if traffic is a condition, then leave earlier. All right? All right. So I see that right now Ryan's not here. It's 8:10. So if anybody ever asks, you can tell them, yeah, Jeff turned in attendance for class today. That's what I should do, is do it in front of each and every one of you. That way when they send me nasty grams and say you didn't do it, I'll say, yes, I did, and I have 8 witnesses, or 7 witnesses, or 6 witnesses, or whatever. All right, so I am on page 212 of your book. You'd like to get out there also, that would be good. I can find it. I think I might have closed it, but oh, there it is. All right, so this chapter again is Chapter 4 on debugging and error handling. All right. I am giving you your test on Thursday this week because we don't have class on Friday. So Wednesday will be the written. We will go over that. We can do that today already. And Thursday will be the hands-on. For the hands-on, you will have a problem that will involve arrays, and that will be the majority of your test. I'm also going to give you an electronic copy of some code. And in that code, I am going to add about 5 errors. You have to find the errors. You have to tell me what type of error each error is and how you'd fix the error. Okay? What's an example? Well, I already gave you this, but if I wanted to say alert, hello, that should bring up an alert box that says hello. But if I accidentally type in alert, that's going to give you an error message. What's the fastest way to find out what those error messages are? You hit the F12 key. And that's going to put you into the Chrome Developer Tools. And you go to Console. Literally, that's what you do. You hit F12, and you go over and you click the Console tab. That's the fastest way to find your errors, in a nutshell. All right. Oh, that was interesting. No, it's not wanting me to play with the size on this. So we have about 5 objectives in here. Recognize error types. Trace errors with dialog boxes and the console. Use comments to locate bugs. Trace errors with debugging tools. Write code to respond to exceptions and errors. So the last part of this chapter talks about something that's known as exception handling. And I've given this kind of analogy before, not to you in here, but to the other class. And that is, you know, my daughter 5 months ago had a daughter, all right? And if she's out walking her child in the child's stroller, and she happens to go by a neighbor, and the neighbor would say, oh, wow, what an exceptional child. My daughter would probably say thank you. Wouldn't you agree? But if you're writing code and somebody says, oh, you have an exception, that's a bad thing because it's an exception to the norm. So when you've got problems, depending on the type of programming language you're using, your code can very well throw exceptions. Those are not good things. All right, so we'll talk about that at the end of the chapter. So, an introduction to debugging. And let's start this hopefully simply, and that is to tell you that there are 3 basic types of errors that you will encounter in a program. And they are syntax errors, runtime errors, and logic errors. A syntax error is a violation of the rules of the language. All right? I'm putting this as simply as I can. You know with JavaScript that it is possible with JavaScript for you to not use semicolons, correct? You may have left them off on occasion and your stuff still worked. But there are certain times that if you don't put a semicolon in, you're going to get an error message. Give you an example. If I type in this, var x equal 3. Well, let's say I did that, and var y equals 7. There's nothing wrong with that. If I want these to be on the same line, in fact, this would work right here. That probably would still work, both of these. That would not work. I would need a semicolon in between those 2 var statements because they're on the same line. So if I didn't have this, I'd get an error message. Does that make sense? All right. Even something like I showed you before, like typing in alert versus alert. That's a syntax error. I spelled something wrong. And what happens when I type in this is the system first looks and it says, oh, is there a system function named alert? It doesn't find it. So it says, okay, did the user write a function named alert? It doesn't find it. So it throws an error or an exception. So when you've got syntax errors, you violated the rules of the English language. All right? Sometimes you hear that, for instance, if someone comes here from a different country and they're trying to communicate with you, rather than saying, excuse me, can you give me directions to, the Wentzville City Hall? They start saying City Hall directions, excuse me, can you, type of thing. What are they doing? They're violating the rules of the language. Now, you can probably figure out what they're asking. That said, most computers have the intellect of an 18-month-old child. All right? So that you've got to put things in the right way, and if you don't, if the system doesn't understand what it is you're trying to do, it doesn't let you do it. All right? Then we've got runtime errors. All right, these are found when you run the program. All right? And some of these bleed into the syntax type of errors. Because technically putting a let in there versus alert is a syntax error, but that said, you probably won't find that out until you run the program. Okay? So there are errors in some programming languages. If you try to divide by 0, the program just blows up. That's a runtime error. But the system doesn't know it's an error until it tries to do the division. Does that make sense? On the other hand, with JavaScript, and you already know this, if you attempt to divide by 0, it gives you NaN. So it doesn't blow up. So every language, the way they handle this stuff is different. All right? And then the last type are logic errors. And believe it or not, these are the hardest to find. Anybody want to take a wild guess as to why a logic error would be the hardest to find?
Because you think you have it right.
Because you think you're infallible. Everybody does. You write code. I've had this happen. I mean, I literally had a situation. Maybe you've heard me say this before. I'll always remember this. It was a good 10 years ago. I had a student. She was a female, and that doesn't matter at all. She ended up being very successful in the program and got a very good job. But she sat there for like about 10 minutes, and she said, I don't know what the problem is. I'm getting this weird output, and it doesn't make any sense. Well, I looked at it like this. I knew what the problem was. Not that I'm that smart, but I could just see what it was. So I kind of pushed her in the right direction. I didn't tell her, but I pushed her, and she found it. She came up to me. She goes, I don't know how that happened because I didn't type it in. And she was dead serious. And I said, well, then when you took a break before, somebody must have come over to your terminal and typed it in. Well, I don't think so. Well, that's the only thing I know of because other than that, you're the only one who's typed anything in there. Yeah, I guess. We all do it. When you are running a program, not so much in a test environment, but if it's class and you're running a program and it's like, I can't find this error. I don't know what the hell is wrong. Yeah, you can ask, but really the best thing for you to do is to walk away for about 5 minutes. Walk down to the lounge, get a soda or whatever, go to the bathroom, and then come back. Because it's amazing sometimes just leaving for a few minutes how that clears your head. All right, and it happens to everybody. I do the same thing. All right, so those are your 3 basic types of errors. So they talk in here about syntax or rules. They talk about logic. And then they talk about the fact that when you've got an error in your program, it's called a bug. I've already given you this so you can read the story of debugging, etc. It's fine, but I don't care. So again, a syntax error. Please look at the terminology here on the bottom of 213. A syntax error occurs when the interpreter fails to recognize code. You may want to mark that up or whatever you do in your book. Why? Because that is literally the text that's on one of the questions on the test. Something like, what kind of error occurs when the interpreter fails to recognize code? And it is a syntax error. As it says, syntax errors can be caused by an incorrect use of JavaScript code or references to things that don't exist. I already gave you the example of a let. All right, here they've got document.writ on the top of page 214 as opposed to document.write. All right, again, everybody does it. The next are runtime errors. As it says, a runtime error occurs when the JavaScript interpreter encounters a problem while the program is executing. Now, they give you an example right here, and it says, is there anything physically wrong with that line of code? If you look up on the screen, there isn't. It's a function call to create recommendation. But if either you never wrote that function or the name of that function was create recommendations, you'd get an error when you run the program. Why? Because you'd be trying to call a function that doesn't exist. All right? So again, it occurs when the JavaScript interpreter encounters a problem while the program is executing. It's called a runtime error because it happens during runtime, when the program is running. All right, and then finally, on 215 is the other type, the top of the page, again, as mentioned, a logic error. Notice as it says, it's a flaw in the program's design that prevents the program from running as you anticipate. This is an important sentence. It's not that you're not getting any output. It's that you are not getting correct output. All right, so again, as an example, if I meant to say up here, so I put in var x equals 7, var y equals 10, and I wanted to say var z equals x times y, so I want it to give me 70. But instead, I accidentally type in var z equals, I don't know, x divided by y or something like that. I don't get an error. The program still runs. It just gives me incorrect output. Does that make sense? Any questions over what those three types of errors are? Because I'm going to put an example of each one on your test. So you will have to tell me the type of error. And if you're not sure, if you go, you know what, this could technically be a syntax error or a runtime error, then you could even put that down. Hit that. Come on. Doggone it. Lovely. That's just friggin' fantastic. There we go. All right. So again, they give you plenty of examples of these in the book. In this chapter, look at this. You have been hired by Tuba Farm Equipment in Fargo, North Dakota to finalize a web app. So notice it says the web app has been coded, but it doesn't work as expected. So throughout this chapter, you will be debugging the code they've already created. All right? And I'm not going to run through any of it. I haven't been, and I'm not going to. I will just tell you, and you already heard this, but on the bottom of page 217, the author says in this green box, the tuba.js file also contains several code errors, which you'll identify and fix in this chapter. For now, you don't need to take any action if you notice an error in the code. All right, so you will be fixing them as you go on throughout the chapter. All right. Now, sometimes when you get an error message, oh, that makes sense. And sometimes it doesn't make a lot of sense. Sometimes the error that you're going to get is something that's going to sound like, it'll literally say something like, object not expected. Well, that's a big help. And you go and you look it up online and it says, this is a generic error message that can happen for a variety of reasons. And I always think, oh, that's 15 seconds of my life I'll never get back. Because it gave me absolutely no help. Now, I will tell you that historically, although it's gotten better over time, one of the problems with Microsoft's, with Internet Explorer, with their development tools, is a lot of times that would be the error message you would get for almost everything. And it was even worse, because if you had a program that was 300 lines long, it would say that the error was on line 301. What that meant was it was somewhere in the first 300 lines. All right. Google Chrome Developer Tools, I think, is better than that. Occasionally, though, you may come up and get an error message that you don't understand. So you might have to Google it. All right. So the author says here, the first line of defense consists of the error messages that get displayed. And they give you an example here. Okay, so function missing closing brace. This function is missing a closing brace. There's the beginning curly brace. Right there. There's no ending one. And the author shows what you get in here. Right there. Missing closing brace is not defined. Well, that's pretty, that's really not a bad error message. Missing curly brace after function body. But sometimes they're going to be very generic in nature, all right, and you won't understand. Now, I'm suggesting that you use Google Chrome and you use Chrome Developer Tools. But if you don't, for whatever reason, Firefox has a very good debugger also. With Firefox, you have to load the debugger in. It's an add-on, and it's called Firebug. So if you want to use that, you can. All right, I think Chrome Developer Tools works every bit as well as Firefox and Firebug. You may not agree with that. And, throughout this chapter, the author will say things that, once in a while he'll say something that you'll be like, well, that's just common sense. And yes, it is. All right. Such as, the author comes through here and says, well, when you debug JavaScript code, it's important you understand how the browser interprets a web page and JavaScript code. A common complaint among professional programmers is that web browsers do not strictly enforce JavaScript syntax. That's not typically the case. Part of the problem is JavaScript does not enforce JavaScript syntax. If you go out and read the ECMA, the European Computer Manufacturer Association rules, they tell you you should have a semicolon after each executable line of code. But you've seen that. I already asked you about that. You can violate that to your heart's content, and 99 times out of 100, it'll still work just fine. Right. It says here, you can compare the way browsers render HTML and interpret JavaScript to the way human beings comprehend language. And it's kind of the example I gave you before, that if you talk to someone who speaks broken English, if English is their second language, you can typically understand it, but maybe not. They might say something to you that you're like, I don't really have a clue as to what you're asking me. All right? Maybe there's a word they don't know how to translate, or they translated something wrong, or whatever. So you will be doing a lot of this stuff throughout the chapter. Return to tractor.htm and open the browser's console. You know now how to open up the console, right? Hit the F12 key and go to console. All right? And they show you an example of that on the bottom of 221 and going on to 222, 223, 224, all right, all the way up to the top of 225. So again, there is a lot of that stuff in this chapter. All right. Then the author says on 225, gives an example right here, gives this program for calculating pay. Okay. Now there's more to this than what I gave you when we did our payroll. With our payroll, we did hours worked and hourly rate, right? And then we figured out whether or not they had overtime. Here they're adding things in like Medicare, Social Security, state taxes, federal taxes, etc. It's more reminiscent of a real payroll example. But someplace in that mess, there's an error in there. So if we turn up a couple pages to page 227, notice what the author has done on this page. He put in a bunch of alerts as you work your way through. Sometimes if you're working on your own program in JavaScript, and for the life of you, you can't figure out what the error message is. All right, a lot of times that's going to be logic errors. So you start putting in window.alert messages. So it'll show you, and as you're stepping through your code, oh, the value should equal this now, what does it equal? And then hopefully you find out what the problem was. So as the author mentions underneath this, all right, remember when you do this, when you use multiple window.alerts, you must enclose each dialog box for your code to continue executing. In other words, if you go to the very bottom and put in one huge window.alert, you're probably not going to find where the problem was. All right, you want to put multiple ones. And I'd put in one. If that one works, I'd comment it out, move down in my code, put in another one. So what they show here in the book on page 227, with all of these alerts, I wouldn't necessarily have them all like that. I'd put in the first one, but I'd comment out these other ones. Then if I know that one works, I uncomment out that one and work my way down like that. But again, everybody goes and debugs in a different way. You all debug in a way that's kind of consistent with your comfort level. All right. So it says here, your contacts at Tuba Farm Equipment have tested the updated version. They're happy that the syntax errors are gone, but they've detected logic errors in the recommendation the application is making. So then you use more alert boxes. If we turn up and look on page 229, you'll see there's even more of them in there. There is an alert, etc. A really good place to put an alert when you look at this example here is if I'm sure this if should be getting hit, and I put an alert inside of the if right at the top that just says something simple like I'm in this if statement, and if that alert isn't getting hit, what does that mean? It means the if isn't true, correct? So if I put an alert here at the top that says alert in if, and I put an alert down here and it says alert in else, and if no matter what my input is, I'm hitting that one, something is screwed up higher up in my program. All right, that's how you figure out what the problem is. All right, you just systematically work your way through it. All right, then there's some more examples, and again, this is stuff that you're going to be running through. If I go up to 231 here, just so you see this. All right, I just want you to see this, that if I'm sitting there and I've got in, here's a BMI program, all right, and I don't want to use that one. Let me grab a different one. So I'm going to come in here and I'm going to say, let's just say I have a JavaScript program, all right, so I've got, I don't know, function main, and I'm just going to keep it real simple, var x equals 7. var y equals 3, var z equals add 2. You probably have seen me do stuff like this before, x and y. All right. Then down here I write function add 2, number 1, number 2, and I just say return n1 plus n2. And this will work, but let's assume it didn't. All right, or let's assume when I got done, if I did this, I could type in, for example, console.log x equals plus x y equals plus y and z equals plus z. And I would want to probably put a \n before each of these. They should go on their own line anyway, but just to be sure. Then what should happen when I run the program, just like this, I'll see nothing on the screen. Did you hear me? I'll see nothing on the screen when the program runs. But when I hit F12, I've got to be in a browser window. So when I hit F12 and I go to console, then I'm going to see down here x equal 3, y equal 7, z equal 10. So you can use the console log function to write things to the log. And you say, well, what's the difference between writing them to the log or doing an alert? With the alert, it shows right on your screen, but you got to close it. With the console log, it shows, but it's in a different window. All right. And again, they give you examples. There's an example of some console logs on the bottom of page 231 and the top of page 232. All right. If I'm writing code, I'm going to go back to this. Let's assume for a second that what I was writing here wasn't going to be this line of code. Let's pretend for a second that this function add2 was going to have 100 lines in it. You with me? I'm just pretending that for right now. All right, so I'm going to comment this out for right now. And if I put in something like this, alert in function add to \n. And then I'm going to say here n1, in fact I can keep going right here, \n. n1 equals plus n1 plus \n, n2 equals plus n2. All right, now that's an alert. I could have done it as a console log. All right, but since I did it as an alert, ideally what that's going to write on my screen is in function add to n1, what values we give it? 7 and 3. n1 equals 7, n2 equals 3, all right, etc. Does that make sense? All right. Putting in a line of code that looks like this before I've done any actual processing, that's known as a stub. In fact, typically in a stub, all you'll put in there is something like this. In function add to, just so I know I'm getting to the function. If I want to make sure my parameters are being passed in correctly, I'll do something like this. All right. So they explain on the bottom of page 232 that main is typically a driver and you use stubs. All right. So I just showed you what they were. All right. On 233, there is 233, 234, 235, 236. There is more. All right. Again, this is the running case example that you're going to be going through in here. In an ideal world, at least, we're going to be done with this by around 9 o'clock. We'll take a break. We'll come back. We'll look at that quiz at the end of the chapter. And I also sent you the review, so we'll go over that. In an ideal world, by 9:30, we're done, which means you've got 2.5 hours today. And if you're all caught up, you can start working on the Chapter 4 stuff. If you don't have any grades right now for the Chapter 1 or the Chapter 2, that means either you handed nothing in or what you handed in was incomplete. All right, so go back and fix that. All the work from Chapters 1, 2, and 3 should be in by the end of the day today. All right. All right. On page 236, the author talks about on the bottom of the page. Sometimes you write code and it's like, this isn't working. And for the life of me, I can't understand why. I don't know if you remember this, but one thing I told you about earlier in the semester that you should never, ever do. If you're writing a 200-line long JavaScript program, you shouldn't write 200 lines and then start testing it. But still, some people do. So if that's the case and your program's not working, comment out everything and start bringing your code back in a line at a time from the top down until you find where the error is. So that's commenting out and commenting in. And they mention that on the bottom of 236, and it goes to the top of page 237. All right. Typically what you'll do, as mentioned on the bottom of 237, is you'll typically combine these techniques. You might comment some stuff out and along with using alerts, etc. All right. Again, more exercises on 239, 240, and 241. On the bottom of page 241, bottom of the page, the author says, tracing errors with debugging tools. I've already given you extra resources, but in this part of the chapter, the author gives you a very simplistic little introduction to the debugger tools. All right. And if you look on the bottom of page 242, the author says, here's how you bring up those windows. I don't know why in Chrome they say you should do a Control-Shift-J. You can. but why don't you just hit F12? Because it's much easier to do. All right. So you will start to use the debugger windows then, and the author is showing it to you. If you look, there's the Firefox debugger window, and there is the Chrome on the bottom of the figure that's on page 243. So the exercise that you do on 244 and 245 is the first time in this chapter that you'll have to use the Chrome developer tools or Firebug or the IE developer tools, depending upon which browser you're using. Does that make sense? All right, so I would make sure just take your time when you do that. One thing you can do, anybody ever done this? I'm asking you this question. Any of you ever done this where you're typing in here, you accidentally click over here? All right, and well, it's not going to show it until I save the file. Let me just save this, and I'm going to throw it on the screen, or right here. I'm just going to save it as hello.js. All right, boom. And you clicked over here. It's making me a liar. There, and you get that. You ever done that? Do you know what that is? That's a breakpoint. You have just set a breakpoint, which said when the program is running and you get to that point, break, which means stop running. All right. Next semester, you'll do a lot of work with setting breakpoints and learning about how to debug C# code. I think that the editor that's put in there in Visual Studios is easier to work with than this is. But you can set a breakpoint. In fact, in the book here, the author defines on the bottom of page 245, a breakpoint is a designation added to a specific statement in a program that causes the program execution to pause when it reaches that statement. So if I put a breakpoint, if you look up on the screen here, right there on line 6, then only statements 1, 2, 3, 4, and 5 run. It stops right there. So if I want to know if this one worked, I don't put the breakpoint here, I put it there. All right, now statements 1 through 6 run, but I go into what's called break mode. All right, there's 3 basic modes that you can be in. Right now I'm not in break mode. Right now I'm in what's called design mode because I'm not running the program. If I run the program and it stops because of a breakpoint or something else, I'm in break mode. If I have no breakpoints in at all and the program is running, I'm in run mode. So those are the three types of modes that you can be in. So the way you set a breakpoint will differ depending on the editor that you're using. But the author mentions on the top of page 246, to set a breakpoint, you click the line number from the line. That's typically the way you do it. With some editors, if you've got a lot of breakpoints set, let's say I set them on 4 lines. Okay? With some editors, if you want to get rid of all of them, you got to click each one of the 4 to make them go away. With some editors, you can right mouse click on any breakpoint and it'll say remove or disable all breakpoints. So you can remove them all at once. So it depends again on the time that you're using, or the type of editor you're using. So the author says again, once you add a breakpoint, Firefox and Chrome automatically stop the program at the breakpoint anytime the statement is run. IE requires that you first click Start Debugging. Now, so, okay, I've run my program. I'm now in break mode, and it's right here, let's just say, right there. All right? And first of all, that wouldn't work. You can't set a breakpoint on a comment. All right? Even though it showed that I could. You really can't set a breakpoint on a blank line because it makes no sense to the system. It's expecting that if you set a breakpoint, it's on an executable line of code, meaning that it's on a line of code that has a semicolon at the end. All right? So you run through an exercise on this where you set a breakpoint on pages 247, 248, 249, 250, and 251. All right. On 251, they go and enhance this. So I'm going to turn up all the way to page 251 here. And on 251, they talk about what are referred to as stepping options. If I wrote code that looked like this, while, let's say here I said var x equal 1, while x less than or equal to 1000, alert x equal plus x. I'm asking you a question, but I'll answer it. How many times is that going to run? The answer is 1,000, right? So I'd have to come in here and also say x plus plus. Okay, so that's going to run 1,000 times. If I'm testing my code, do I really want to have to run through this 1,000 times and see 1,000 alerts? I don't. That'd take the whole period, and I probably still wouldn't finish. All right, so what I can do is I can do what's called step in, or step out of code, which means that I can tell it, okay, you're here at the beginning of that loop, just go right to the end of it. All right. So the author says here, the first option is stepping in or step into it. It executes an individual line of code, then it pauses. So it'll stop, okay? In some editors, for example, with Visual Studio, I think it's the F11 key. It'll run your code a line at a time. So you press F11, it'll run that line of code. You press F11 again, it'll run the next line. All right. The way you do it depends on the browser that you're using. You will, again, have an exercise where you will go through this. The step over allows you to skip function calls. The step out executes all remaining code in the current function. So what I showed you before was basically a step out. All right. So you will go through another exercise that uses the stepping options on 251. It shows you visually what it'll look like on 252. There's your buttons. There they are in IE. There they are in Firefox. There they are in Chrome. So the author is constantly showing you what you should be doing and what it should look like. All right. And you'll run through the 6 steps that end on the top of page 253. Right there. Or 8 steps. You can also put what are called traces on variables. When you put a trace on a variable, what it does, it allows you to run the entire program, and you'll get a little window that will show on the screen that will show you at any time what the value of whatever variable or whatever variables you put a trace on, what their current value is. All right? And that's referred to as tracing program execution. So as it says here, you can use variable lists, all right, and watch lists. You will go through an exercise on that. They show you, again, on the bottom of 253, how to set it for IE, and on the top of 254, how to set it for Firefox and Chrome. Then they have you walk through another exercise where, again, they show you this visually on page 255. And the exercise goes on to 253, 254, 255, 256, 257, and 258. And the top of 259. So it's a long exercise. And this is many of the things that you do for this exercise. All right, I can't tell whether you've done them or not. If you make all the changes so your program runs, that's all I can grade you on. But when you are doing your test on Thursday, and if you're trying to debug and you can't figure it out, now you've got a lot of different options you can use to try to figure that out. All right. All right, jumping up to the bottom of page 259, bottom of the page. This is on the test. One of the questions on the test, I don't know which one, I don't remember, don't care, but one of the questions on the test asks you what the call stack is. So you can see, if you look on this page, you can see what the call stack is. It's the ordered list that is maintained, etc., etc. Rather than doing that, let's look at this in English, what the call stack is. I'm going to try to show you. All right? And the example that I give you is going to be kind of a goofy example, but I'm doing it to just demonstrate what's happening. All right, so I've got my program here. I'm not going to worry about any of this stuff, okay? But I'm just going to come down here, boom. Okay, there's my function. I'm not going to do anything in here except I'm going to call another function. So I'm going to call this function 2. And for function 2 to work, I'm going to pass in N1 and N2. All right? And this is going to look kind of stupid, but there's a method to my madness. If you just bear with me for a second. And function 2 and we'll just call this, I don't know, X and Y. This is going to call function 3. And it's going to pass in X, and it's going to pass in Y. Oops, Y. Finally, I get down to function 3, and we'll say that has A and that has B. And this will return A plus B. Now you might look at this code and go, that's really stupid code. Why would you ever do that? The only reason I'm doing it is to show you the call stack. All right? So what happens is the system it says, okay, I'm in main. Oh, I'm calling function add2. And add2 is going to have in it X and Y. All right. Oh, now I'm calling function 2. And that's going to have it in N1 and N2. Oh, now I'm going to call function 3. And that's going to have in it, what did I make it, X and Y again? It really doesn't matter, but just so you get the idea, okay? What I'm doing is, as I add these things, I'm adding to what's called the call stack, all right? And the reason that that's important is not so much in this language. When you were in your 4th semester and you write a Java program, you'll be like, I don't understand why this doesn't work. Because you'll do something and the program will blow up. And what it will show you is the entire call stack. It'll show you every single function that was called in your program. And on those, if you've got 10 functions, 9 of them will be system functions. 1 of them will be a function that you wrote. Which one do you think will be the one in error? The 9 system functions or the one you wrote? The one you wrote. Almost always. All right? When you go through this, so this says I get done with function 3. So that has to return the results to function 2. That has to return the results to function to add. That has to return the results to main. Does that make sense? That's called unwinding the stack. All right? So they formally in here define the call stack as being the ordered list maintained by the JavaScript processor that contains all procedures, all right, that have been called but have not yet finished processing. And they will show you an example of this. What do I mean? Well, what I mean is if we turn up and we look starting on the bottom of page 260, you will do yet another exercise where you run through this. And that's on 260, 261, and 262. All right, the rest of the chapter, which starts on page 263, and it goes pretty much the rest of the chapter to about page 277, talks about handling exceptions and errors. All right, we're already almost 50 minutes in, so what I'm going to do is we will break this thing up, and let's take a break. It's 8:57. Let's come back at 9:10, and we will finish up this chapter, go through the quiz at the end of the chapter, and go through the test review. All right? So again, come back, please, around 9:10. Thank you.